Most AI coding agents are restricted to static data and simulated environments. Recently, however, a single repository introduced a method to grant these agents full command over a live, active browser. This chart tracks the project's GitHub stars, which rocketed from 0 to over 5,700 in a matter of weeks. Despite that growth, the entire capability is powered by a single JavaScript file. AI agents frequently report that they are browsing the web, but their view is limited. They typically fetch simplified text summaries, which fail at login screens, interactive forms, or dynamic content. A project called Web Access addresses this bottleneck by connecting into your actual Chrome browser. It operates through your existing sessions, cookies, and login states to interact with the web exactly as you would. Standard agents cannot process interactive elements on their own. This skill provides the technical bridge, allowing an agent to navigate and manipulate the live web with stateful access. The core design of Web Access relies on a specific decision-making framework, rather than hard-coded scripts. It provides the agent with a philosophy of browsing, a set of instructions for prioritizing different methods of data retrieval. A three-layer architecture prioritizes access. Layer 1 uses standard built-in tools for quick searches. Layer 2 uses Gina Reader to convert text-dense pages into lightweight Markdown. Layer 3 uses Chrome DevTools protocol to bypass logins and directly command the browser interface. By presenting these options inside a single configuration file, the agent gains the autonomy to weigh the trade-offs of speed versus access. It chooses the right tool for the job based on the obstacles it encounters. Consider a practical scenario where you need to research trending posts on a highly protected social media platform. Because these sites use aggressive anti-bot measures, traditional web scrapers are blocked almost immediately. Web Access avoids this by operating inside your active Chrome profile. It loads dynamic content using your existing authentication, appearing to the website as a standard human session. To increase its utility, the developers added a script called find-url.mjs. This allows the agent to query your local browser history and bookmarks to find specific destinations. If you ask the AI to find the internal company dashboard I looked at last week, it can independently locate the unindexed URL from your history and open the page. Once the page is open, the agent uses a technique called shadow DOM piercing. It runs an evaluation script that scans through hidden internal boundaries that typically block standard CSS selectors. By utilizing active logins and local data, the tool leverages your specific clearances. This transforms the agent into a direct proxy of the user. While mature competitors like browser use exist, Web Access is built on the SKILL.md standard. This makes it compatible with almost any agent environment, from Claude Code to Cursor, without needing a complex setup. However, this compatibility comes with technical risks. We can see high commit activity on the left, but 0% test coverage on the right. There are currently no automated tests for a tool that assumes total control over your web browser. The project also faces severe platform constraints. It only functions on Google Chrome, and the documentation is written exclusively in Chinese, which creates a barrier for global enterprise adoption. The architecture itself creates a security trade-off. The tool exposes a local HTTP API on port 3456. While it is restricted to your machine, an open port that can execute browser commands expands your system's potential attack surface. Stability currently depends on the developer's rapid response to the community. When Windows users reported path conversion errors, the maintainer migrated the scripts to Node.js to fix them, but the project still relies on a single individual. This single, untested JavaScript file has effectively removed the technical partition between an AI agent and the authenticated web. As these agents manipulate browser sessions and pierce internal site structures, the gap between AI research and human-level web navigation is closing rapidly.